Welcome to the Unit 2. Definition and MCQs. Let's dive. Laboratory hazards and precautions definition. Laboratory hazards refer to potential risks and dangers present in a laboratory environment, including chemical, biological, physical, mechanical, and radiation hazards. Precautions are the safety measures taken to prevent accidents, injuries, or exposure to harmful substances, such as wearing protective equipment, proper handling and storage of materials, and following safety protocols. Steps to handle a chemical spill in the lab. Short version. 1. Assess the spill, identify the chemical and its hazards. 2. Ensure safety, wear PPE and avoid direct contact. 3. Contain the spill, use absorbents or neutralizers to prevent spreading. 4. Ventilate the area, open windows or use fume hoods if needed. 5. Clean up properly, use appropriate materials and dispose of waste safely. 6. Report the incident, inform the lab supervisor and document the spill. 7. Decontaminate and wash hands, clean the area and wash thoroughly. Preparation of solution and its types. Preparation of a solution. 1. Determine the required concentration and volume, decide the amount of solute and solvent needed. 2. Weigh or measure the solute, use a balance for solids or a pipette for liquids. 3. Dissolve the solute, add it to a suitable solvent, example water, and stir until fully dissolved. 4. Transfer to a volumetric flask, if needed, add more solvent to reach the exact volume. 5. Mix thoroughly, shake or stir to ensure a uniform solution. Types of solutions. 1. Based on solvent type. Aqueous solution, solvent is water, example salt water. Non-aqueous solution, solvent is not water, example alcohol-based solutions. 2. Based on concentration. Dilute solution, low amount of solute. Concentrated solution, high amount of solute. Saturated solution, maximum solute dissolved at a given temperature. Unsaturated solution, more solute can be dissolved. Supersaturated solution, contains more solute than normally possible. 3. Based on phase. Solid solution, solid solute in solid solvent, example alloys. Liquid solution, liquid solute in liquid solvent, example vinegar. Gaseous solution, gas dissolved in gas, example air. Laboratory hazards and precautions, MCQs. 1. Which of the following is not a common laboratory hazard? A. Chemical hazard. B. Biological hazard. C. Physical hazard. D. Social hazard. Answer, D. 2. Which type of hazard includes exposure to toxic, flammable, or corrosive substances? A. Biological hazard. B. Chemical hazard. C. Mechanical hazard. D. Radiation hazard. Answer, B. 3. What is the main purpose of wearing personal protective equipment, PPE, in a lab? A. To look professional. B. To protect against laboratory hazards. C. To perform experiments faster. D. To avoid following safety rules. Answer, B. 4. Which of the following is an example of a biological hazard? A. Acid spill. B. Electrical shock. C. Bacteria exposure. D. Fire explosion. Answer, C. 5. What is the first step to take in case of a chemical spill in the lab? A. Start cleaning immediately. B. Identify the chemical and its hazards. C. Mix chemicals to neutralize the spill. D. Leave the lab without informing anyone. Answer, B. 6. Which of the following should not be done in a laboratory? A. Wearing safety goggles. B. Eating and drinking. C. Keeping chemicals labeled. D. Using fume hoods for ventilation. Answer, B. 7. Which safety equipment is used to wash chemicals off the ice? A. Fire extinguisher. B. Emergency shower. C. Eye wash station. D. First aid kit. Answer, C. 8. What should you do if you accidentally break a glass beaker in the lab? A. Pick up the broken pieces with bare hands. B. Leave it and walk away. C. Notify the supervisor and use a brush and dustpan to clean it up. D. Wash it with water. Answer, C. 9. Which precaution helps prevent fire hazards in a lab? A. Storing flammable chemicals near open flames. B. Keeping fire extinguishers accessible. C. Ignoring safety signs. D. Wearing loose clothing near flames. Answer, B. 10. Which type of hazard involves burns, electrical shocks, and sharp objects? A. Biological hazard. B. Chemical hazard. C. Physical hazard. D. Radiation hazard. Answer, C. 11. What is the function of a fume hood in a lab? A. To store chemicals. B. To provide ventilation and remove hazardous fumes. C. To dispose of biological waste. D. To clean glassware. Answer, B. 12. What should you do if a fire breaks out in the laboratory? A. Run out of the building without warning others. B. Use a fire extinguisher if safe and alert the supervisor. C. Pour water on all fires. D. Continue working as usual. Answer, B. 13. Which of the following is a mechanical hazard in a lab? A. Sharp cutting tools. B. Toxic gas exposure. C. Chemical burns. D. Radiation exposure. Answer, A. 14. Why should chemicals be stored in labeled containers? A. To make the lab look organized. B. To easily identify and handle them safely. C. To mix them faster. D. To keep the shelves full. Answer, B. 15. What is the best way to prevent contamination in a biological lab? A. Eating food in the lab. B. Wearing gloves and sterilizing equipment. C. Mixing chemicals randomly. D. Using broken glassware. Answer, B. 16. Which safety measure should be taken when handling corrosive chemicals? A. Wearing gloves and goggles. B. Smelling the chemical to check for danger. C. Pouring chemicals quickly to avoid spills. D. Using bare hands to transfer chemicals. Answer, A. 17. How can electrical hazards be prevented in a laboratory? A. Using damaged wires and plugs. B. Keeping electrical equipment away from water. C. Touching electrical switches with wet hands. D. Overloading power sockets. Answer, B. 18. Which of the following is an example of a radiation hazard? A. Fire from alcohol spill. B. Exposure to X-rays. C. Inhaling toxic fumes. D. Falling on a wet floor. Answer, B. 19. Why is it important to keep the laboratory clean and organized? A. To reduce the risk of accidents and contamination. B. To make experiments faster. C. To impress visitors. D. To create extra workspace. Answer, A. 20. Which emergency procedure should be followed if a person is exposed to hazardous chemicals? A. Ignore the exposure if it seems minor. B. Immediately wash the affected area and seek medical help. C. Wait until symptoms appear before taking action. D. Keep working to finish the experiment. Answer, B. Preparation of solution, MCQs. 1. What is the first step in preparing a solution? A. Mixing the solute and solvent. B. Weighing or measuring the solute. C. Heating the solvent. D. Filtering the solution. Answer, B. 2. Which of the following is an aqueous solution? A. Alcohol in benzene. B. Sugar in water. C. Mercury in gold. D. Air. Answer, B. 3. A solution where water is the solvent is called A. Non-aqueous solution. B. Saturated solution. C. Aqueous solution. D. Supersaturated solution. Answer, C. 4. A solution that contains more solute than it normally can at a given temperature is called A. Saturated solution. B. Supersaturated solution. C. Dilute solution. D. Unsaturated solution. Answer, B. 5. Which of the following is not a type of solution based on concentration? A. Dilute solution. B. Homogeneous solution. C. Saturated solution. D. Supersaturated solution. Answer, B. 6. In a solution of salt and water, salt is the A. Solvent. B. Solution. C. Solute. D. Precipitate. Answer, C. 7. Which of the following is an example of a gaseous solution? A. Vinegar. B. Air. C. Sugar water. D. Brass. Answer, B. 8. The solvent in a non-aqueous solution is A. Always water. B. A liquid other than water. C. A solid. D. A gas. Answer, B. 9. Which type of solution has a high amount of solute compared to the solvent? A. Dilute solution. B. Concentrated solution. C. Unsaturated solution. D. None of the above. Answer, B. 10. Which of these is an example of a solid solution? A. Sugar in water. B. Oxygen in nitrogen. C. Brass, copper plus zinc. D. Carbon dioxide in soda. Answer, C. 11. What is the main function of a volumetric flask in solution preparation? A. Measuring mass of solute. B. Measuring the exact volume of solution. C. Heating the solution. D. Filtering impurities. Answer, B. 12. If more solute can still be dissolved in a solution, it is called A. Saturated. B. Supersaturated. C. Unsaturated. D. Dilute. Answer, C. 13. Which factor does not affect solubility? A. Temperature. B. Pressure. C. Stirring. D. Color of solute. Answer, D. 14. Which of the following best describes a homogeneous solution? A. The solute is not fully dissolved. B. Components are evenly mixed. C. It contains visible particles. D. Solvent and solute are immiscible. Answer, B. 15. When making a solution, why is stirring important? A. To separate solute from solvent. B. To increase the rate of dissolution. C. To evaporate the solvent. D. To form crystals. Answer, B. 16. Which of the following is an example of a liquid solution? A. Air. B. Sugar in water. C. Mercury in silver. D. Foam. Answer, B. 17. What happens when a saturated solution is heated? A. It becomes supersaturated. B. It crystallizes. C. More solute can be dissolved. D. It becomes a suspension. Answer, C. 18. The process of dissolving a solute into a solvent is called A. Filtration. B. Dilution. C. Solution preparation. D. Dissolution. Answer, D. 19. If a solution appears cloudy and has undissolved particles, it is likely A. True solution. B. Suspension. C. Colloid. D. Saturated solution. Answer, B. 20. What is the main characteristic of a concentrated solution? A. It has a low amount of solute. B. It contains an equal amount of solute and solvent. C. It has a high amount of solute. D. It cannot dissolve more solute. Answer, C.